Hello children, this is chapter gravitation and the first topic is universal law of gravitation. Important topic, Newton's universal law of gravitation. What is according to this? According to this, every two objects of this universe are attracting each other with some force. That force is called force of gravitation. Okay, every two objects are attracting each other with some force, that is called force of gravitation, and that force of gravitation is directly proportional to, okay, we'll have to write directly also, directly proportional to product of their masses, and inversely proportional to, inversely means 1 upon square of the distance between them. This is equation number 1, this is equation number 2. We can combine both the equations and we'll get it as directly proportional to product of the masses and inversely proportional to square of the distance. Now removing proportionality, we all know what will come, a constant will come. This constant is G. What is G? Universal gravitational constant. Okay, gravitational constant. And its value is, we'll have to learn the numerical value of capital G. It is 10 to the power minus 11, 6.67 10 to the power minus 11 unit, Newton meter square per kg square. Coming to the numerical now. In this numerical, mass of Earth is given. Let us note down mass of Earth as 6 into 10 to the power 24 kg. Then mass of Moon is given. This is mass of Moon, which is 7.4 into 10 to the power 22 kg. If the distance between Earth and Moon is this, so let us note down the distance also. 3.841. Okay, it is 3.84 into 10 to the power 5 kilometers. So we can please convert into meters. 3.84 into 1000 meters. And capital G is given. We have to find out the force. So it is simple. It is a substitution based numerical in which only formula needs to be used. So F is equal to G, mass of Earth. Sorry, let us take the bigger notation. Mass of Earth, mass of Moon, the two objects are mass of Earth and mass of Moon upon distance square. Now we have everything. Mass of Earth, mass of Moon, distance. So let us substitute. Let us try doing that. This is 6.6 into 6.67 into 10 to the power minus 11. Mass of Earth is 6 into 10 to the power 24. Mass of Moon is 7.4 into 10 to the power 22. Otherwise, you can check the values properly. This is distance and its square has to be written. So 3.84 into 3.84. I'm just writing twice. Okay. This is 10 to the power 5. So this also I'm writing twice. So basically it will be 10 to the power 10 downwards. Okay. Let us check the value of mass of Earth once more. So yeah, it is 6 into 10 to the power 24. Now let us do. This is 24 and 22, 46. 46 minus 11 is 35. So rest of the quantities you will multiply. I am just dealing with powers of 10. So it is 10 to the power 35 and this is 10 to the power 10. When it will go up, it will be subtracted. So 10 to the power 25 will be left and this portion you can divide and check. So Newton will be the answer. Let's get to the next topic, which is acceleration due to gravity and free fall. Let us come to the next topic now, which is free fall. So children, what is free fall? When an object falls freely under the action of gravity alone, nothing else, only gravity. So only gravity when that is free fall. Free fall means the object falls only under gravity. No other force should act on the object. no other force should act on the object. For example, this is a stone, this I've dropped, so now it is falling under gravity. It should not be tied to a thread. So that is what we mean. This man is falling under gravity. Okay. So after that we have another topic. Let us see that. When an object falls freely, then what happens? Then slowly its velocity increases. You can see in this pic that the man has dropped a ball. Just observe very carefully. Something very interesting is there. You can see in first second, this is the distance traveled. In second second, this is the distance traveled. In third second, this much. Fourth second of free fall is this much. And after fifth second of free fall, distance is this much. It means its speed is continuously increasing. Its velocity is continuously increasing. Direction is same, that it is coming down. But the amount of distance traveled is greater in the same time. That means speed is increasing. And the increase of speed means there is some acceleration. And who is the cause of the acceleration? The Earth. Earth is the cause of the acceleration. So that acceleration is called acceleration due to gravity. You can see here, while falling, there is no change in direction of motion. Yes, the object falls down. But due to Earth's attraction, there will be change in magnitude of velocity. There will be an increase. Any change in velocity involves acceleration. And whenever an object falls towards Earth, an acceleration is involved. This acceleration is due to Earth's gravitational pull, Earth's attraction. So this acceleration is called acceleration due to gravity. And it is denoted by G. This is a symbol. This is the SI unit, meter per second square, like an acceleration. And its value is 9.8 meter per second square. And in numericals, we will take it as 10 also. So you can see here also in this diagram, in this picture, there they have measured the velocity. Okay, the man has thrown the ball down, and now you see at the highest point velocity is 0. So u is 0. After 1 second, this is the velocity. After 2 seconds, this is the velocity. After 3 seconds, this is the velocity. They have measured. You can also calculate. After 4 seconds, this is the velocity. You can see velocity is increasing continuously. That means an acceleration is involved. And who is the source of acceleration? Earth. So that acceleration is called acceleration due to gravity. Okay, now we have expression for acceleration due to gravity. We have to obtain the expression for acceleration due to gravity. So let us do that. Expression for acceleration due to gravity. That is small g expression we wish to know. Okay, so this is an object and this is Earth. Okay, mass of object is m and mass of Earth is capital M. So you can label these, and distance is obviously radius of Earth. This is mass of object. This is mass of Earth. The distance between two is radius, approximately equal to radius, because Earth radius is too much. So this is a separation. Earth radius is too much. Okay, so this is distance, or you can say radius of planet Earth, of Earth. Okay, so what is gravitational force? Using Newton's law of gravitation, what can we write? Using Newton's law of gravitation, this is equal to G, mass of first object, M, mass of second object, that is mass of Earth, upon distance square. So this is my gravitational force. Again we can write gravitational constant G, mass of first object which is an object, mass of second object which is Earth, and upon distance square which is radius of earth square. Now also from Newton's second law, this was written due to gravitational law. Now we are writing due to Newton's second law of motion. We have F is equal to ma, and during free fall, what do we know? During free fall, A is equal to acceleration due to gravity. And during free fall, A is equal to acceleration due to gravity. So we'll keep here G. So F is equal to mg. This is my first equation. And this gravitational force is my second equation. Put both the forces equal. Gravitational force is causing the motion. Put both the forces equal. One is mg and the other one is gmm by radius of earth square. Small m cancelled. So we have obtained the expression for acceleration due to gravity as this. Where we should know all the symbols, name of all the symbols. Do we know all the symbols? Yes. This is gravitational constant. Capital M is mass of earth. R is radius of earth. And we know all the values. All the values are known to us. This value is 6.67 into 10 to the power minus 11. Its value is 6 into 10 to the power 24 kg. And radius of earth is 6400 kilometer. When you will substitute here and calculate, then G will come as approximately this. So everyone has to learn this value. Or in numericals, we'll be using it as 10 meter per second square. Okay, children. So very simple derivation is there. Final formula is this. This relation is also called relation between G and G. For example, in exam, question can come relate G and G. So the same derivation you have to do for as you have done for expression for acceleration due to gravity. So let us see these InText numericals. Solve numericals. A car falls off a ledge. Okay, it falls from a height. It drops to ground in 0.5 seconds. So time is 0.5 seconds. G is given, that is acceleration due to gravity is 10 meter per second square. What is the speed on striking the ground? So car is falling from here. And what do we know? That when something falls from up, then U is 0. And something goes down, when something goes down, U is 0. And when we throw things up, then V is 0. So right now U is 0, car is falling down, 0 meter per second. So we have to find out velocity. The simple we'll use first equation of motion. We should always search for the equation which is connecting these. T, U, this is A, this is acceleration. We have to find out V. First part is V. So we can simply use a first equation of motion, but we should write that using first, don't write law, equation of motion. So can we use U is 0, A is 10, time is this. So you can obtain. Let us see what is the average speed. So what is the formula of average speed? Average velocity. The formula is initial velocity plus final velocity by 2. That is 0. Final velocity you are calculating here. Let us calculate. V is equal to 0. 0 gone. A is 10. This is 0.5. So this is 5 meter per second. Let us substitute here 5 by 2. 5 by 2 is 2.5 meter per second. This is average speed. Coming to the next part. How high is the ledge? What is the height of the ledge? Height is distance. Do we have U? Yes, 0. Do we have T? Yes, it was 0.5 seconds. And G was 10. They had given in the question. G is nothing but acceleration. So U, T, A, S. Which equation? Second equation of motion. So using second equation of motion, What is second equation of motion? S is equal to ut plus half a t square by a is g. So all of you get used to it. 0 into t is 0. A is 10. Time is 0.5. Square. A is g. So 0 into t is 0. So it is 5 into 0.25. So it is 1.25 meters. Let us see the next question. Let us see this. An object is thrown vertically upwards. So it has been thrown up. So something has been thrown up. So it will reach highest point. And what do we know about highest point? At highest point, velocity is 0. So final velocity is 0. The object has been thrown from down towards up. Initial velocity we don't know, but at highest point velocity is 0. So when it is thrown up, then v is 0. In previous question it was thrown down, so u was 0. Please understand. So here it is thrown up, so v is 0. It rises to a height is displacement. Displacement is 10 meters. Calculate the velocity with which it was thrown. So u is asked, initial velocity, the velocity with which it was thrown, and time taken. So we have so many quantities. Velocity, final velocity is 0. We should write height is given, u is asked, and time is asked. Now one quantity that has been given that you should use now is acceleration due to gravity, A. Because it is going against gravity up, so we will take it minus 10 or 9.8. You can choose. I will take 10 because calculations will be simpler. So I have A, I have S and V. How to find out U? S, A and V. So we'll use third equation of motion. What is third equation of motion? V square minus U square is equal to 2AS. This is height. So, and A is G. You can write like this also. Final velocity is 0. U is to be found. This is 2. This is minus 10 because it is going against gravity. It is given 10. So this can be written as minus U square is equal to minus 2 into 10 into 10. So minus minus cancel. U square is equal to coming 2 into 10 into 10. So U will come as this thing. Now 10 will go out. Root 2. This is U. What is the value of root 2? 1.4. So it is 1.414. You can use 14 meter per second is U. Now there is one more part in which they have asked what is the time? In which time will it fall down? It will go up. Yeah, time taken by the object to reach the highest point. Again, the same quantities, we need time. We just need time. Final velocity is 0, you remember? Initial velocity you have found as 14. And acceleration due to gravity, that is A, that is G, is equal to minus 10. So let us use first equation of motion. U plus 80, V is equal to U plus 80. This is 0, this is 14, this is minus 10 and this is T. So 14 will come this side, it will be minus 14 is equal to minus 10 into T. So T will be equal to minus minus cancel 14 by 10, okay, which is equal to 1.4 seconds. So rest of the topics and numericals will be in the forthcoming videos. Kindly prepare these properly.